All right, all right. Welcome, everyone. This is the fifth presentation of the last day, unfortunately, of the J Champions Conference. I'm like, I have no words to say how happy I am to be the host today, and It's my absolute pleasure to welcome our next speaker, someone who proves that cloud native engineering doesn't have to be boring. It's Holly Cummings. She has worn a lot of different hats, as many hats, as a full stack developer, software architect, consultant, and innovation leader. Nowadays, she wears the IBM hat as a senior principal software engineer on the Quarkus team. By the way, this is an awesome team of engineers where she helps to shape the future of modern Java applications and makes the cloud cloudier. Like she also is a Java champion, Java 1 rockstar, an internationally recognized speaker, and one of the rare people who you can talk about JVM internals, performance, sustainability, testing, and anything that you would like to talk about Java, making it all genuinely engaging. Today, Holly will show us how to deliberate misuse Quarkus, which is a little bit different, and from hallucinating LLMs to Minecraft observability and grapefruit benchmarks. She proves through ridiculous demos how powerful Java and Quarkus really are, and they really are. Do not hesitate to ask any questions during the presentation. We'll be here managing everything. And welcome, everyone, Holly. Yay!
Thank you very much. I need to get my apologies in early because all of those hats that you mentioned, I think I'm going to be trying to wear them all in this one presentation. And I saw someone describe it earlier today as chaos, and I thought, oh dear, but I think that they might be right. So I have learned a lesson, which is demos are hard. Trying to do a whole bunch of demos in this at the same time is even harder, but we'll see where we go. So it should be good fun.
Awesome. So the floor is yours.
Thank you.
And welcome again.
Thank you. So I want to start just with a little bit of an introduction to Quarkus for those who don't know. And one of the questions that I get asked most often is, well, Quarkus is really cool, and I've seen it in demos, but is anyone actually using it in production? And the answer is absolutely yes. So there's all sorts of enterprises using Quarkus, like various telcos, various retailers, and various banks. But actually, you don't want to hear about that, do you? That's not why we're here. So let's step away from the production usage of Quarkus, and let's jump right into some of the other things that you definitely shouldn't do with Quarkus in production. So I want to start with a little project here. So I've got just a simple Quarkus project downloaded from code.quarkus, and I'm going to start it up. And I'm going to kill whoever is hogging the process. See, this is the problem with so many demos, is something somewhere is going to be using a process. So it's... And I never remember how to read the netstat output as well. Cool. So let's kill that one as well. Okay, so let's start Quarkus again. And hopefully this time it will start. So cool, so it starts. So what I'm going to do is I'm going to click W to bring up my application. And what we can see is I've just got the sort of the landing page here. With so many demos, it's kind of hard to remember what my endpoints are, but luckily the dev UI or even just the landing page will show me what my endpoints are. So if I click on hello, I've got, you can see this is just the basic output from a boilerplate Quarkus application. But if I'm honest, probably everybody's seen this before. It's a little bit boring. Can we do better? Yes, we can. So let's go back to our code. Let's go back to the right code. And I've added a little filter class here, which at the moment isn't doing anything. We can all see it wasn't doing anything. But if I add a server response filter annotation on it, and so you can see this is just a JBoss filter. If I go back to my browser and I retry, I have different output. So what's happening here is I've applied a translation layer. And so instead of, it takes the normal output for adults and it runs it through a Gen Alpha translator so that the young people who are, maybe off doing their Python or whatever can learn the joys of Java. And it will be a bit different each time. So you can see we've got the 6 7s in, we've got chicken jockey in here. I have to say I don't entirely understand the output, which is kind of the point, but it will produce output. So first demo done. Let's go back to slides. So I'm going to show a lot of code. I'm going to show a lot of repositories. I've got them all linked in the slides. So should you wish to have your own Gen Alpha translator, the code showing how to do it is there. Was this an easy demo? Yeah, it was really easy. It was just one class. Is this useful to you? Well, if you have children of the right age, it might be useful to be able to speak Gen Alpha. But more generally, this kind of interception and filtering is really simple, really easy, potentially useful for lots of things. So the takeaway here is server response filter. But that was kind of a simple translation. And can we do more? That translation, it was all application code that was doing the translation. But I'd like to do something different. So let's go back to let's close that window. The reason I'm looking confused is I've lost my cursor. Hey, where's my cursor gone? Okay, there we go. I've got my cursor back. So let's close down the Gen Alphaizer. Get rid of that. And let's go on to which hopefully will close the thing listening on the port. And let's go on now to Quarkus jokes. So let's start up Quarkus again. So, what we're going to do is I'm going to get rid of this. Which is one I prepared earlier. And I'm going to do Quarkus create an app. I'm going to go into my app and I'm going to do Quarkus dev. And so here I have the world's most boring basic app. Let's look at the dev UI. If we make that a little bit more of a manageable size, you can see I've got the dev UI. Nothing very exciting here. But what I'm going to do is I'm going to go to my repository. and I'm going to go to my POM. Normally, if I want to add an extension to a Quarkus application, I can just use Quarkus add, but this extension hasn't been published for reasons that will become obvious. So I'm going to have to add it manually. So I'll just pop it in here, save, and I should see my application refresh. And if I go back to the dev UI, you can see I have my new extension. This extension, again, isn't really intended for production. It's just intended to show some of the capabilities of Quarkus. And one of the capabilities, in particular, some of the capabilities of the dev UI, and one of the capabilities that we've added recently is this workspace view. So what this is showing me is the code of my application. So you can see there's that hello from Quarkus REST message that you get in all of the default applications. Why is this interesting? Why would I want to see my code in the browser when I've got an IDE? It's sometimes useful actually for things like this where I've got so many windows that it's a bit difficult to manage them, but that wasn't actually the use case. The use case here is that so the Quarkus dev mode and dev UI allows you to see all sorts of things about your application. You can see your endpoints, you can see your CDI beans, you can see dev services, and we can do that because we know a lot about your application. And then the next natural step is, well, if we know so much about your application, in a world in which we have generative AI, can we help you more? Can extensions use generative AI to help you debug problems? When an error comes through, can we combine knowledge of the error with knowledge of your application to give you richer guidance towards a solution? And the intention here isn't to replace things like Cloud Code or those specialist tools. It's to provide something where you can combine the really deep knowledge of your application that comes from actually being the runtime of your application with some of those capabilities. I mentioned generative AI. Of course, that's where a lot of the conversation is, but this doesn't have to be generative AI. It can be any kind of introspection of the code and any kind of manipulation of the code. So the extension that I'm showing now has no generative AI in it. It's just a code helper. Well, I say helper in quotes because we will see. So I've got various actions that the extension has exposed. These are all coming from the joke extension. They could come from any other extension. This is new capability, so I don't think there's very many extensions that have it yet, but this is something that's now coming down the pipe, which is kind of cool. So I can reverse my code. As you can see, this should not be done in production. This is completely useless. So let's reverse the reverse. Or I can do things like manipulation. So when I reversed the code, it was just showing it to me in the UI, but this action will actually manipulate my code on disk. So I can save that. And then if I go back to my IDE and bring up the right window, then you can see in my source, I will have completely uncompilable code. I have gone from a working application to a broken application with the help of the extension, but you have to admit it's kind of funny. So would you want to do this? Well, I don't know. Not like that. So let me get rid of that one. And then let's go back. So you can see source code is available. Was this an easy demo? Yeah, it was really easy. All of that dev UI work and all of that extension was my colleague Philip's work. I'm just showing his demo. What do you take away from this? The dev UI now have assistants to help you write and debug code. So this is something that's pretty unique to Quarkus, and it's really quite cool. Now, I mentioned, this isn't going to compile. Code like this, the Quarkus runtime has no chance of understanding. And in general, the Quarkus runtime is pretty oriented towards Java, not stupid things like this. But the Quarkus runtime is not only Java. So we have various extensions for Quarkus, including several that are for alt languages. So most of these are JVM languages. So you can do Groovy, Kotlin, Scala. But one of these alt languages extensions is the Bon Jova extension. And what Bon Jova is its support for a JVM language that's a bit more niche than Kotlin. And it's the Rockstar language. What is the Rockstar language? The Rockstar language started because people in this sort of the golden age of overactive recruiters, people used to get really annoyed about recruiters talking about rockstar developers and looking everywhere for rockstar developers. And someone said, if we made a language called Rockstar, that would just really confuse this whole thing. So this was just, a throwaway comment on Twitter. And it got turned into an actual programming language. And there's implementations for Python, for Rust, for JavaScript, but there wasn't a JVM language. And this seemed like a huge gap to me. So I fixed that. So what I'm going to show is I'm going to show the Bon Jova application. So what I've got here is I've just got a little application with some tests, because of course I've got tests. And if I go to the dev UI, you can see that I've got the Bon Jova extension there. What can we do with the Bon Jova extension? Well, like a lot of the extensions, you can see what endpoints you have. Here, every extension is a .rock file. If I go to my workspace, that should come up in a moment to show the code. Should come up in a moment. Nope, it's not going to come up in a moment. Normally it would show if it wasn't a live demo, but I can go to my IDE and I can show you some of this code. So what I've got here, this is the extension, and then I've got my actual application. As instead of having a Java folder, I've got a Rockstar folder, and I've got a whole bunch of programs in Rockstar. The Rockstar syntax is kind of interesting. I don't have time to go through it. Some of it looks kind of familiar, so we've just got shout instead of echo. Some of it gets a little bit more obscure. So if you wanted to implement FizzBuzz in Rockstar, for example, it would look like this. The whole intention of Rockstar is that your code should look like an 80s rock ballad. And I gave a talk about the work that I'd done on Rockstar once, and the feedback came back at the end of the talk. Someone said, well, I don't think I'd really use this in production, which I was quite depressed by, because of course you shouldn't use this in production. If your intention is to use this in production, I've done something terribly wrong. But it is kind of interesting to see how far you can push the syntax of a programming language, and also how far you can push the capability of Quarkus. So I'm going to show another one. So this one, it's sort of not really clear what this is doing. My dreams were ice cold, life unfulfilled, waking everybody up, taking booze and pills, shout my dreams. So let's have a look. at what's going on here. So if I go to my Rockstar endpoints, and if I go to guest.rock, I can see the code again, and I can also try it out. So for every Rockstar program, the extension has automatically added an endpoint so that I can try it out. And what we've got is 3.41414. That looks almost like pi, but not quite. But we can fix that. So if I go back here, my dreams were ice cold. If I just take out that cold, and then let's try that again. So if I refresh, I've got pi. So you can see what I have here is I have Rockstar as a JVM language. I have live reload because of Quarkus, which means I can edit my Rockstar programs on the fly and see the update. Amazing. I tried to do the billion row challenge in Rockstar, and I got quite far, but you'll be shocked to hear I didn't actually get the billion row challenge working in Rockstar. The number syntax for Rockstar and what you were just seeing there is that they're called poetic literals. Instead of representing numbers as digits, you represent them as arbitrary words, and the digit is the length of the word. So, not so useful, but kind of cool. Was this an easy demo? This was absolutely not an easy demo. So this is something that Hannah Ambretz and I did, and it took about a month. And every time my manager asked me what I was working on, I was, really worried because I knew at some point he was going to say, "Holly, you have to stop spending, all your time on this. You have a day job." The lesson is friends don't let friends write compilers. Writing the Rockstar compiler was really hard. The bytecode generation was hard. The parsing part was really hard because it's a flexible syntax. So lesson learned. What does it mean for you? Well, the Quarkiverse, you'll notice that extension was there in the Quarkiverse. And it's an extension for writing your program as 80s rock ballads. So what you can take from this is that the Quarkiverse is really very welcoming to new extensions. Also, should you ever wish to write a compiler, just don't, but should you ever wish to do it, Antler is probably the way to go. Antler is cool technology. A while after doing this, I saw this sort of went viral briefly. So this is someone who decided to make a Gen Alpha programming language. So you notice this has just combined my first two demos. And so, you'd use yeet instead of import and that kind of thing. And this I thought was, at first I was depressed because I thought, wow, someone else has done the same stupid thing as me. I needn't have bothered. But it's kind of interesting to see how the different ways in which these two were created. So for Rockstar, Dylan Beattie wrote the spec. He wrote it in a pub late at night. So the cost was about 5 beers and 1 napkin. And it just took one night to crank out the whole spec. For Cursed, obviously there is no spec. The whole language was vibe coded. He just pointed Claude at it and let it go. On the implementation side, the implementation was free if you don't count my salary. And it took about 3 weeks. For Cursed, the implementation was done using AI. It was definitely not free. It cost $36,000 in tokens. And it took a really long time as well. So he had it burning tokens for about 3 months in order to get that. I still can't decide which is stupider. 3 months and $36,000 of AI time, or 3 weeks of human time who could be doing something better. Probably probably neither is ideal. But this does bring us to the topic of Gen AI in general. There's a lot that can go right with Gen AI, but there's quite a few pitfalls as well. And one of the main pitfalls that we see all over the place is hallucinations. And the interesting thing about hallucinations is it's not like they're a bug where if we just coded the LLM better, we could fix it. It's actually fundamental to the technology. The system is designed to make stuff up that is believable. Some of the stuff that it makes up that's believable is actually not true. This is a problem that we've known about for a long time. There's a ton of research into fixing this, but there's something interesting about where things are going. Some research came out recently, and they looked at the rate of hallucination when summarizing public information. And with O1, so that older model, they had a 16% rate of hallucination, which is kind of bad. With O3, it went up to 33%, so it's going in the wrong direction. With O4 mini, it went up to 48%. So it was, I mean, other things were getting better, but the rate of hallucinations was certainly not. There is a solution. Well, certainly there's a partial solution, which is to put guardrails on. One of the challenges with guardrails is that if you knew the correct answer, you wouldn't need to be using the AI. So often a pattern that makes sense is to take your AI and add on more AI. And the pattern is called LLM as a judge. And so the idea is that you take the output from one LLM and you run it through a different model. And hopefully if they both agree it's true, it's more likely to be true. But of course, hallucinations are, I mean, they're a problem in all sorts of ways, but they are kind of fun. Going away from them, kind of boring, right? So let's do something different instead. So let's get rid of Rockstar. If I can find my cursor, my invisible cursor. Okay, so we will get rid of Rockstar. And I've got another project, which is the hallucination generator. So as with everything else, I'm going to start with Quarkus Dev. While that's loading, what I've got here is I've just got a chatbot using LangChain for J. So I've got a system message saying, you're a knowledge base, give an answer, and then, or take a question and give an answer. So I'm going to click W to go to my window, and here is my chatbot. And so let's bring it up, and let's try something like how many R's are in the word strawberry. So this is a classic thing that LLMs really struggle with. And let's see what it gets. As you can see, this is a classic thing that LLMs struggle with. I'm using the Gemma 3 1 billion parameter model. It finds it difficult. Some other things it probably finds a little bit easier. So if I say, is wine a healthy drink? Let's see what it does there. Yeah, okay, so it failed on strawberry, but I think on wine, that's probably correct and boring. Can we do better? And by do better, I mean make the answer funnier. So what I'm going to do is on my fact service, I'm going to add a guardrail. So I'm going to put output guardrails, and I'm going to call my hallucination detection service dot class. And so with this annotation, I'm saying, please pass through the output through the hallucination detection service. This is the wrong one. So this is another lang chain for J registration with an LLM. So here I've got your fact detection system, rank the answers. But what I actually wanted was the hallucination guard. So let's call that the hallucination guard. Oops. And which actually implements the interface. So this implements the output guardrail interface. And so if I go back to my browser, let's see if anything has changed. So let's start a chat and let's try again. How many R's in the word strawberry? And what it will do is it's thinking for a little bit. And you can see I've got some new output. So my judge has correctly rejected the answer that there are 6 R's in the word strawberry, and it's retried. But unfortunately, on the second try, it's gone back through, and the main LLM again said there are 6 R's in the word strawberry, and the judge said, oh yes, that's definitely true, which is a little bit unfortunate. And the other thing is that what my judge here is trying to do is find a true answer. So it rejects the untruth and it accepts the truth. I want to do the opposite. So on my hallucination guard, instead of rejecting when the truthiness is low, I want to reject when the truthiness is high. So let's go back and try that. So let's reload. And let's try blueberries just for variety. How many R's in the word blueberry? And so you can see again, it answered that the word blueberry had 8 letters and it rejected that as plausible. And then it tried again and it accepted it as a lie. So if you're looking at this and thinking the answers aren't really what you would hope for in any way, that's pretty true. But I want to show something else. So if with blueberry, my guard isn't really accurate. I tried adding lots of examples to help my guard function better. It still didn't really work. So what this is showing is that LLM as a judge, you have to be really careful with it. LLMs are always non-deterministic, but that judge pattern seems to be particularly hard to get right. So for example, one of the things I found was that LLMs are naturally stateless, and your LLM library will usually have some sort of memory implementation because otherwise the conversation makes no sense. But when it's retrying because it failed the guardrail, it will pass back the previous attempts, and that will definitely influence the judge in a way that you maybe don't want. But let's try, is beer good for you? And so you can see we got, sort of a pretty believable answer, which it rejected. And then it kind of gave the same answer back and accepted it, which again wasn't really what we wanted. And this answer, I think we all agree, is very boring. True, but boring. So let's do something else to try and push it in the direction of being silly. So in my fact service, I pass through the question. But what I'm also going to do is I'm going to pass through some context. So I'm going to say some context and then take that argument that I had defined on my interface. So this could be anything, by the way. I define this API, so I could do context2 and then call that context2, for example. And let's go back and see what happens with that context. So let's refresh and say, is beer good for you? And nope, so this is still pretty boring. Unfortunately, all of these are true answers. Let's nudge our context a little bit. If I look at my fact service, where's that context coming from that I'm passing in? I'm actually generating the context with it for the purposes of the demo. I'm generating the context using another LLM service. And what I'm trying to do is I'm trying to generate a story based on 2 hedgehogs eating carrots during space travel. So that you can see that this is pretty ridiculous. And here is my story generator. And it's generating a story. And my story has to be at least 100 words long. Let's change that to make my story 300 words long. And then let's see if that affects things. So let's reload here. Let's try is wine healthy? And it's thinking. Nope, you can see we've got several boring answers, and then eventually we got a boring answer that my guardrail misjudged. So let's try a different prompt. Let's go back to how many R's in strawberries. And then what's it? Okay, so what's happened here? So a couple of strange things have happened. The first is that the judge should have rejected this and it didn't, and I don't know why. But leaving that aside, it answered that there are 147 R's in the carrot. And so what's happened is you can see if I look at the traffic going back and forth to my prompt, oh, actually, obviously, I forgot which way I had the polarity on my hallucination guard. It said it was only 10% likely to be true, so it accepted it because we're trying to amplify the hallucinations. But if I look at my context, you can see that going back up here, I've got some context, and there's all this story about hedgehogs and carrots. And the word carrot appears enough times in that context that it came out in the answer for how many R's are in strawberry, even though it obviously has nothing to do with it. And the lesson here is that you have to be really, really careful with your memory and really careful with your context, because having extra context there seems like it's going to be a good thing, but at some point it really starts to distort the behavior of the LLM in a way that you maybe don't want unless you're deliberately trying to get stupid answers for a demo. So let's close that. Was this an easy demo? No, I thought this demo would be so easy because I'd used guardrails before, and I just thought all I have to do is reverse the polarity of the guardrails. But in order to actually get a good demo, I mean, it's always hard doing demos with LLMs because they're so non-deterministic. But what I needed for this demo as well is I needed something that would, if I tried something like what's the chemical formula of water, it would always be correct. And if I tried something like how many R's in strawberry, it would almost always be wrong. And so I needed to find like the right combination of the model and the prompt so that I could tilt it either way. And that was really, really hard. And you can see in the demo, actually, I didn't really succeed. And I've tried really hard. So I think, then the other challenge I had is that I couldn't actually get the LLM as a judge to be very accurate. I used a larger model, but even with my larger model, it got swayed by things like the context to not do a proper evaluation. So what does this mean for you? Guardrails definitely really important in your toolkit when you're using LLMs, just because they are so non-deterministic. If you use the LLM as a judge pattern, it seems like it gets you out of having to have an independent evaluation of what's coming out of your LLM. LLM as a judge is still going to have the same problems as other LLMs. Also, be really careful with your context. So the more context you have, the lower your response quality is going to be past a certain point. And if your context grows, that's going to make your generation more expensive, and it's going to make your generation lower quality. So be careful with that. One of the other things, of course, that you are probably going to want to have with any LLM-based solution is really good observability. You saw briefly on the previous demo, what I had it logging the responses and logging the requests. And just that level of logging was really useful to be able to debug and to identify where context was causing problems or that kind of thing. But of course, that's only going to be part of your solution, something like a system out print line or a log. You're also probably going to want a more complete observability stack. This is something that Quarkus makes easy. So there's sort of a general observability pattern, which is that you'd have your Quarkus framework and your user code. Your application would embed the framework and the code, and then it would also include a whole bunch of extensions, such as OTel, such as Grafana, so that you can have the LGTM stack. Then when a client talks to your application, what will happen is that, and of course you might have multiple clients, your application can't just hold its log information to itself. It has to send it to somewhere else. Otherwise, in the cloud, when the application gets shut down, you lose all of your observability information. So you'll probably have an observability stack somewhere that is accepting these events, which again is probably going to be sort of, Grafana, that kind of thing. With Quarkus, if you don't want to stand up the whole observability stack every time you're doing local development, but you do want to see if it's working, what you can do instead is you can have your dev service. So normally you would use your observability client, your browser, or whatever, see what's going on in your stack. For local development, you can have that whole stack running inside the application or managed by the application as a dev service. So standard pattern. But this is really boring, right? We can do better. We don't want the LGTM stack. We want something a little bit more exciting. What we want is Minecraft. How is Minecraft possibly an observability client? Well, we can use the exact same patterns with Minecraft as we can use with more boring stacks. So we have an outside server running outside our application, and we can see what's going on in that server with a client. And when events happen in our application, we can send events, we can use an extension to send events from our application to this external server, which happens to be Minecraft. What allows us to do that is the fact that Minecraft is moddable, so we have a Minecraft mod as well. If we're running locally, we maybe don't want to stand up a whole separate Minecraft server, so we can run it as a dev service. So let's see how this works. So let's bring up the right window. Okay, so I've got the Minecraft window. And what I've got is again, just a simple application, which is a to-do app. So let's start that. I think that stack trace is from when I killed it earlier on my first demo. So I'm going to start my application. And you can see that it starts a dev service for Postgres. And I think it will also be saying somewhere it's starting the dev service for Minecraft. And so if I go to my dev UI, I've got the usual extensions, and then down here, I've got observability with Minecraft. Clearly, I should have put a logo on this extension, and I didn't. But with my extension, what can I do? Well, let's spell localhost correctly. I've got my to-do app, and I can add list items. So I can say, do talk, and I can add them. So far, so boring. But where it gets interesting is if I connect my Minecraft observability client. So I've got my Minecraft client here, and I'm just going to tile my windows, which is the hardest part of this demo. So let's close all of those actually, and close all of those. And let's bring up a new window and let's tile it. And let's go back to localhost. So I've got that. And now I'm going to go and I'm going to connect with my Minecraft client to my Minecraft server. And I'm going to join that. And then I have, so you can see I got a little message saying hello from the Quarkiverse. And I've just got a normal Minecraft world. If I go back to Firefox, and if I say eat supper, then you can see I've got an event tracked here, and I can add other events. So I can say hi, and I've got my events coming here. I have it configurable, of course. So if I go to my application properties, instead of having a chicken, I could have, for example, a pig. So let's change that to be a pig. Let's go back and let's bring that up, and then, let's bring that up, and then I can say, have lunch. And that's not spelled correctly, but you can see we've got a pig. If I say hi again, and then I say hi again. So here, will be an error because yep. So if I have the same entry twice, that's an error condition. And so what happens is we get, I don't know why we got a frog, because we get an explosion. And so that's why we have bacon. So there'll be an explosion. Yep. And our pig died. But we can go further as well, because this is all just normal code. And instead, what I can do is I can make it use an LLM to generate my animals. So instead of just having the normal Minecraft animals like pigs and chickens, I can have an LLM generate them. So if I'll show you quickly what that code is doing. It's got a chat model. I can't use the full Quarkus LLM integration because it's an extension. So I'm using vanilla LangChain4j, and I define my model. And then in here as well, it's serializing structured JSON into an object, which then at the other end gets converted into a Minecraft entity. So if I go back, if I go back to here and here, and then here, let's reload here. Oh, there we go, an event from that. And I think that was saying something bad happened, but we will see. So if I say sit down, oh, yep. So what it's saying is that I've defined a model that doesn't exist. Let's fix that. Let's uncomment that. And let's go back to here, and then let's go back to here. And then if I say sit down, let's just reload that just to be sure. And if I say sit down, there we go. It was just being slow. You can see there's quite a lot of latency when I switch to using the LLM to generate my models. Oh dear, I got blown up. But you'll also see that I said sit down, and the event that happened there was influenced by what I set. So if I chose, for example, to do something like find a ghost, then after the irritating delay while it goes up, I should find, where's my model? Oh, it hasn't come. Let's try again. So say be spooky. And then after the delay, it's quite well hidden, isn't it? Okay, well, we'll leave that. You can see the idea. The lesson is that maybe you shouldn't use LLMs for something like a game where it's really sensitive to latency. But I do quite like the idea of enriching what's going on in the application, what's going on in the observability with generative AI, so that we can take what's going on in the application and interpret it. Which, again, probably for strict observability, you might not want that interpretation, but there's definitely some things that you can do with that. Okay, so there's that. All of the actual tracking of the events is done with interceptors. So that's really cool. The other thing that's really cool here is the dev services. So you'll notice I had to start the Minecraft client. I didn't have to start the Minecraft server. It was just all done, and it was Minecraft, which is pretty cool. And you can see here's the AI ones as well. You can see I was trying to have it be spooky, and then it will choose a spooky name for it. This sadly was not an easy demo. The extension part was really easy, but making that Minecraft mod was really hard. Minecraft APIs, they have a different approach to API stability to what we have in the Java world. They tend to lack documentation. They change between minor versions. And also I've never written a game, so what I hadn't really appreciated is how complex the logic is to get the client and the server agreeing, because they have to have a shared understanding of the world. And so when I was trying to make AI generated entities, I was pretty limited in what I could change, because the client and the server had to agree in advance on what could be changed. So my original idea was that I would have the LLM generate images, but that couldn't work because all of the images had to be pre-registered with the client. So sometimes, what we do seems really sophisticated, but then when you look at other domains, you realize that what they're doing is also really sophisticated as well. I also, on the LLM side, I really appreciated that I could have the LLM generate type-safe objects because of how LangChain4j works. So I was actually passing these type-safe objects across to the client, but you can also see that the latency was pretty bad. It's not a good idea for that kind of thing. So next, Quarkus is really fast in all sorts of ways. Let's see that in action. So what I've got here is, oops. Just going to bring up a container for reasons that will become sort of clear. In this container, I have a Quarkus application that has been built to a native binary. So if I do, I'm going to start the runner. You can see I've not given it an alias, which would have made it easier to type. So this is the runner that's come from a native application, and I'm going to say hello. And what you really want to be noticing here is how very fast that was. I'll do it again. It started, I have a command line application built with Pico CLI and Quarkus native, and it is doing it pretty much instantaneously. And if I go back here, it's generated an image, and I have my meme. So I can say hello twice. And then if I refresh that, it updates. So this is cool, and it's fast. This sadly was not an easy demo. It turns out, I mean, Quarkus native, it has risks. And GraalVM in general, it has risks. In general, you will be better off with JVM mode. JVM mode will also go, it will have a higher throughput. It will also start pretty darn fast, and it avoids some challenges that come with native mode. One of those challenges with native mode is graphics on the Mac. The support just isn't there. So I tried a whole bunch of things, and I tried, fussing around with what was a build time class and what was a runtime class and the GraalVM config. I tried the GraalVM community container. None of that worked. In the end, the Mandrill container, which is a Red Hat build of GraalVM, it did work, and I had it running. So I had running that container on my Mac. I was able to get the images. So Pico CLI, it's really cool. You can do command lines that start so fast. Native makes it extra cool, but do be aware that native does have pitfalls. There are areas that you will try and make it work with native, and it just doesn't. So with native, you probably want to go native if you need it, but don't go native if you don't need it. So the last thing, I think I have about 30 seconds left because I had too many demos. But I really I won't do the demos, but I want to talk quickly about some work that we've been doing to have a transparent public benchmark to show that Quarkus is fast, because we talk a lot about the startup time of Quarkus, and we talk a lot about the memory consumption of Quarkus, and we don't talk so much about the throughput of Quarkus. And the throughput of Quarkus is actually, in a way, its best feature. This is work that's been going on for many months, because writing a benchmark, anybody can just knock out a benchmark, but writing a really good benchmark is hard. And we're trying to be really careful with it and get external validation and that kind of thing. So you can see our work in progress at this URL. I sometimes show it live when I have time, but of course that does come with some cautions, which is that you shouldn't run a benchmark on your laptop. That it's not reliable hardware in that sense. It will get the CPU will get throttled in unpredictable ways. Also, if you try and drive load while you're also doing streaming, it's going to be even more unreliable. So what we do is, you can run it on a laptop, but we also have it running in controlled labs. And the thing that's important here isn't just like a, sort of a speed contest, because if you have higher throughput, what that means is that your hardware requirements are in general lower. And that means that your runtime costs are lower. We can try and illustrate this by looking at sort of simulating a container environment. When we do this, what we see with the results that we get in the lab, I mean, the exact numbers will vary, but we can sort of go from that throughput and that memory consumption to work out what size container you would need. And you will, in general, need a much smaller container with Quarkus. And that means that your cost will be much smaller, which is cool, right? So yeah, the takeaway here is that Quarkus uses way fewer resources, which means it costs way less money to run, which is kind of awesome. There's a financial aspect, but there's also an energy aspect. Talking about kilowatts and that kind of thing, kind of boring. So what I really wanted to do is do a demo where we could power a computer with a lemon. When I started looking into it, I realized I was maybe, I couldn't do it just with one lemon. I thought maybe I'd need a few lemons or, maybe a lemon array, something like this. But I found a video where someone had made a computer that ran on potatoes. And I thought, oh, great, I can follow their model, until I realized that they needed 9,000 potatoes. So at this point, I started to realize that this wasn't going to be feasible. I could work out from information about how much energy typical Amazon instances use. Each potato generates about 0.7 milliwatt, or each lemon 0.7 milliwatts. So if I had a container like what I'd measured Quarkus needed, I would need about 17,000 lemons to run my demo for an hour. So the takeaway is that if you wanted to do this demo, you would need 17,000 lemons to do it with Quarkus and 40,000 lemons to do it with Spring. So many fewer lemons with Spring, or with Quarkus. If you did want to actually try the measurement locally, we're experimenting with scripts for that. They look a bit like this. You can run it locally. I would run it locally, but I have run out of time. But what's the takeaway? So the takeaway is, if you're going to do load testing, don't do it on your laptop while you're doing a live demo, but also use the proper tools. Don't use JMeter, use Hyperfoil or Work2. If you want to measure energy, this is an evolving area, but if you're on a Mac, Powermetrics does give you that data. Was this an easy demo? No, I couldn't do it with the lemons. I really wanted to do it with the lemons. And even on the energy measurement side, our industry is really still figuring out how to do this. So we've done a lot. What have we done? Way back, like a whole hour ago, we translated output with a filter. We transformed code with an extension. We compiled rock ballads to bytecode. We amplified hallucinations, sort of, although that one didn't go so well. We used Minecraft as an observability client. That one did go well. We made memes with a CLI. So cool. And I say confirmed, that was kind of optimistic because I just showed it on the slides, but we saw that Quarkus does do a lot with very few resources, which means if you wanted to power your computer with lemons, you would need fewer lemons if you were running Quarkus. And with that, thank you very much. The slides are here along with links to the various repositories where you can try out these ridiculous things at a slightly gentler pace. And thank you.
Yay! Ollie, thank you so much. The guys are basically not having questions, but just they are impressed in the chat, like how many demos you did and all those different impressive things. There's one funny question that I just want to bring it up, like from Francois. Like, how jealous are the kids when you tell them that you get paid for like Minecraft at work?
That is such a good question, because it's so true. All the time I was working on this demo, my kids would like wander into my office and they'd be exactly that. They'd be like, you're playing Minecraft and I'm not allowed to play Minecraft because I'm supposed to be doing homework, but you're playing Minecraft. How is that fair? So yeah, we have the best job.
Yeah, and Francois is also saying that like there is no such a thing as too many demos, and actually, I also got impressed though. Not about the how many demos, but how different you can apply and how you can see Quarkus in action in a super easy way, actually.
Yeah,
And
thank
it's
you.
pretty impressive. So the guys, everyone, Johan is here as well, like making some comments that everyone is impressed.
Hooray!
So again, thank you so much for your presentation, guys. Don't forget to follow her. Get the QR code, get the talk, and I see Holly sometimes in because they're going less to the conference, but she's all to the conference here in Europe. If you see her, have a chat with her. She's super nice. Is amazing, and she has like really great talks and like in this way like super funny with a lot of good content and actually hard content that looks like really easy when she explains everything. And like she's an awesome speaker, that's why. And thank you all, and see you soon. Bye
Thank
bye
you.
guys.